Okay, hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all my friends and Dr. RISWAN. Okay, so our project is about solving Knapsack problem using linear programming. Okay, before I start to explain about this project, I would like to introduce my group member. Okay, first, me, myself, I know Mariza binti Maizlan. Okay, second, Nur Alia Najihah binti Ahmad Kasim. Third person is Siti Nur Shakira binti Jani. And the last one is Nur Husna Akila binti Lokman. Okay, so there is 4 members in this group. Okay, so this is the content of the project, which is we have project background, project objective, problem statement, significance of project. So I would like to talk about project background first. Okay, linear programming is widely used in a variety of industries. It is widely utilized in mathematics and to a lesser extent in business, economics, and for new engineering problems. Formally, the Knapsack problem is often expressed because of the above integer linear program. The applied mathematical relaxation of that integer program just converts the variables x from being binary in bracket 0, 1 to a true number in bracket 0, 1. So the applied mathematical realization may be a problem that's in P, while the above integer linear program may be a problem that's NP complete. Okay, so the Knapsack problem is an example of a combinatorial optimization problem, which is a branch of mathematics and computers concerned with determining the best object among a set of alternatives. Okay, so the given item in the Knapsack issue have two properties at a minimum: an item's value, which influence its importance, and an item weight or volume, which determines its limits. Since an exhaustive search is not possible, one can break the problems into smaller subproblems and run it repetitively. The problem solver only must decide whether to require the item or not support the load which will be accepted. However, if it is a program, recomputation is not independent and would cause problem. This is where linear programming technique can be applied. So, next we have project objective. Okay, the project objective for the first one is to pack the Knapsack in a way that the resulting value is maximized, but the capacity limit is not exceeded. The second one is to formulate an equation that will optimally pack a Knapsack with items of various weight. So we proceed to the problem statement. Okay, the problem statement first is Knapsack problem is a combinatorial optimization problem that entails determine the quantity of each item to include in a collection given a set of objects, each with a weight and a value, so that the total weight is less than or equal to a given limit and the total value is as large as possible. The second one is the issue frequently arises in resource allocation, as decision makers must choose among a set of non-divisible projects or activities while working under a strict budget or time constraint. Okay, the Knapsack problem is concerned with finding an optimal subset of item with the highest value while respecting the capacity of the Knapsack. The value of a Knapsack item to be positively or negatively influenced by the selection of other items. To put it another way, an item's value is unknown until a decision is made concerning another thing. Okay, so we proceed to the significance of project. This research will provide a new perspective in solving the Knapsack problem by using linear programming. The Knapsack problem is to maximize a concave objective function over linear constraint, which makes the problem a convex optimization problem. Convex optimization problems are known to be solvable. Through the research, students can solve the problem of large size. Linear programming models are preferred to be solvable. More efficient tools such as ILOG, CPLEX. Next, we proceed to the data analysis and discussion. There is 7 questions have been prepared, included gender and age. So, questionnaire will distribute to the student, especially the student who had taken the subject SMQ 3043. So, a total of questions have been prepared that I said before. The first and second questions are about the demographic of the respondent, which is gender and age. Okay, so the first question, which is gender, a total of 11 female respondents and a total of 9 male respondents answered this questionnaire. The second question is about age. A total of 20 respondents were in the age range of 21 until 24 years old. Okay, so we proceed to the next question. For the third question, this question asks the respondent whether they have ever used linear programming to solve a knapsack problem. A total of 16 respondents have used linear programming, while 4 others are not. Okay, so this shows that there are still SMQ 3043 students who are not proficient in using linear programming to solve knapsack problem. The next question is the application of knapsack problems that require pro-efficiency in using linear programming. This question is about, let us consider that the capacity of the knapsack W is equal to 80 and the list of provided items are shown in the following table. Find the maximum profit gained by applying fractional knapsack. So basically, this question is about find the maximum profit gained by applying fractional knapsack. So among the answer given are 220, 160, 240 and 280. A total of 14 respondents have answered 240, and while 4 respondents answered 160 and only 1 respondent has answered 220 and 280. So the exact answer for this question is 240 and majority answer is right. Okay, so for the next two questions are about greedy algorithm. First, consider the weight and values of item list below. Note that there is only one unit of each item. The task is to pick a subset of these items such that their total weight is no more than 11 kgs and their total value is maximized. So, moreover, no item may be split. The total value of item picked by an optimal algorithm is denoted by V optional, and a greedy algorithm sorts the item by their value to weight ratios in descending order and pack them greedily. Starting from the first item in the order list, the total value of item picked by the greedy algorithm is denoted by V greedy. So the value of V optional and V greedy is, so the answer is 16. So a total of 10 respondents answered 16, while 7 respondents answered 17. Next, a total of 1 respondent and 2 respondents for answer 18 and 15. So this question also the majority has answered is right. So the next question is about greedy algorithm. So in the greedy algorithm, do we need to arrange the item by density in a descending order? There are still 6 respondents no to this answer. So obviously there are still respondents who are less skilled about this greedy algorithm. Lastly, the question is about rucksack. Rucksack problem is the other term of knapsack. So a total of 60 respondents answer yes and 4 respondents answer is no. So we jump to the conclusion. A total of 20 respondents participated to answer this questionnaire. As a result of the study, there are still respondents who are less skilled in using linear programming to solve this knapsack problem. This is because there are still respondents who answered the wrong answer in this questionnaire. Hopefully, respondents take this opportunity to train themselves using linear programming to solve knapsack problem. So that's all for our group. Thank you.